You've seen the movies, right? Giant asteroids, heroes saving the day? Well, forget all that. The real threat from asteroids is totally different. So, which ones should we actually be worried about? Let's get into it.
Okay, so our story kicks off not with some brilliant prediction, but with a total out of the blue surprise. An event that was a real wake up call, showing us just how vulnerable we are.
All right, picture this Chelyabinsk, Russia. It's the morning of February 15th, 2013. Out of nowhere, an asteroid, and we're talking something heavier than the Eiffel Tower, just slams into our atmosphere. And about 30 kilometers up, it just explodes in a flash that was literally brighter than the sun. But here's the crazy part. At first, nothing. Just silence. Can you imagine that? You see this incredible, blinding flash in the sky, and you hear absolutely nothing. So of course, people are confused, they're curious, they run to their windows, and for a full 90 seconds, they just stood there, watching the smoke trail get bigger and bigger, with no idea what was hurtling towards them. And then the shockwave hit. Bam! It just blew out windows in thousands of buildings. And get this, it injured 1,500 people. And most of those injuries, they were from flying in glass, because everyone was crowded around the windows staring right at the thing that caused it, totally clueless about the consequence that was racing right at them.
Now, you're not going to believe this. This is the real kicker. On that exact same day, astronomers were high-fiving each other. Why? Because they had perfectly predicted a close flyby of another asteroid, one called Duende. But the one that actually hit us, the one that caused all that damage, yeah, they missed it completely.
And look, Chelyabinsk wasn't some one-off fluke event. The scale of this problem is, well, it's kind of staggering. Since 1988, Earth has been hit by over 1,200 asteroids bigger than a meteor. You want to guess how many we saw coming? 5. Just 5. And even then, we never had more than a day's warning. So what is going on? Why do we keep getting caught by surprise?
To figure out why we're so bad at this, we got to understand what exactly we're hunting for in space and just how incredibly hard that hunt really is.
So, what are these things anyway? Well, asteroids are basically just the leftovers from when our solar system was being built, like cosmic construction debris. You can think of them as pieces of failed planets. Some are just loose piles of gravel and rock, kind of like a floating rubble pile. Others are solid chunks of metal, the actual core of some ancient, long-dead protoplanet. Cool, right? Yeah, finding them is a real cosmic needle in a haystack situation. There are a few big reasons why. First, they're small. I mean, even a really dangerous one might only be a few dozen meters across, which is just tiny in the insane vastness of space. Second, they're super dark. Think of them like lumps of coal floating out there that reflect almost no light. And third, our telescopes have the impossible job of trying to spot these faint, tiny, moving dots against a backdrop of millions of bright, stationary stars. It's a nightmare. So all of this creates a huge, fundamental problem for anyone trying to hunt these things. See, our best chance to spot an asteroid is when it's opposite the sun from us, in our night sky, so it's fully lit up like a full moon. That's why, like 85% of all asteroid discoveries are made in that one little patch of sky. But there's a dangerous flip side. It means we have a massive blind spot right in the direction of the sun. And guess where the Chelyabinsk asteroid came from? Yep, straight out of the sun's glare. Okay, so we've established they're ridiculously hard to find. But what happens when a bigger one doesn't miss? Let's pivot and talk about the sheer, absolutely terrifying power of an impact. Take a look at this. This is Barringer Crater in Arizona. This was carved out by an iron asteroid about 50 meters wide. Now you think, okay, they must have found the asteroid buried at the bottom, right? Wrong. The impact was so unbelievably energetic, we're talking 600 times the power of the Hiroshima bomb, that the entire 50-meter projectile was just gone, instantly and completely vaporized on impact. Okay, so let's really put these sizes into perspective to see what we're dealing with. First up, remember Chelyabinsk, the rock that injured 1,500 people? That was about 20 meters across. You know, small enough to cause a whole lot of chaos, but really just the beginning of this terrifying scale. Now, more than double that. The asteroid that literally vaporized itself to create that huge Barringer crater, that was 50 meters wide. So now we're moving from regional damage to something that can carve a permanent scar into the Earth. And then there's the big one, the dinosaur killer.
This thing wasn't meters wide. We're talking 10 times kilometers wide. The jump in destructive power here isn't just double or triple, it's just on a completely different level, a true extinction level event. So what happens when something that big hits? Well, the impact throws tons and tons of debris way up high, and then it all starts raining back down all over the globe. As all that rock re-enters the atmosphere, it heats the air so intensely it's like the whole sky lights up. An expert described it as being like you're inside a toaster oven. The sky itself becomes a source of heat, literally cooking life on the surface. And yeah, that's what happens to the dinosaurs. Okay, so that is pure nightmare fuel. But let's bring it back to right now. What's the actual practical threat that you and I face in our lifetimes?
And here's some good news for a change. Thanks to some really dedicated surveys, we've basically tracked the orbits of all the really big ones, the 10-kilometer plus asteroids. And we can say with a whole lot of certainty that none of them are on a collision course with us for at least the next 100 years. So you can sleep soundly tonight. A dinosaur-level event is not on the horizon.
But here's where it gets tricky, and this is really the most crucial point. The good news is we've found pretty much all of the extinction-level dinosaur killers. We've even found most of the country killers. But the bad news? When we get down to the 100-meter city killer size, we are basically flying blind. We are missing the vast majority of them. And these are asteroids big enough to completely wipe a major city off the map. One of them could be heading our way right now, and we'd have no idea.
So that leads to the ultimate question, right? If we do see one of these city killers coming for us, what can we actually do about it? I mean, think about it. We have rockets, we've got nuclear weapons, we have some of the most brilliant scientists on the planet. Surely there's got to be a plan, right? Some kind of defense system? Well, the blunt, kind of sobering answer is no, there's nothing we can do. And that's not just me saying that, that's a direct quote from Professor David Jewett, a guy who served on a committee that studied this exact problem. The bottom line is, with our current tech, if we spotted a city killer asteroid on its way here today, we'd be totally helpless to stop it.
But hold on, what about all the stuff we see in movies? Bombing it? Well, that sounds good, but most of these are rubble piles, and the fragments would probably just pull themselves back together with their own gravity. Okay, what about attaching a rocket to gently push it off course? Great idea, but we don't have rockets powerful enough, and you'd have to keep that push going for centuries. Lasers? Solar sails? All awesome, fascinating ideas, but the technology is decades, maybe even centuries away. Heck, even just evacuating a city is a logistical nightmare. Think about it. We can barely evacuate a city for a hurricane that we can see coming a whole week away.
So that's the bottom line. If we can't stop them, and we can barely even run from them, what's the one thing that everyone agrees we absolutely must do first? We have to find them. That's it. The only viable plan we have right now is to build the telescopes and fund the surveys we need to map every single one of these potential threats. It's like we're living in a cosmic shooting gallery, and right now we're not even watching the sky. So the real question isn't just whether we can stop the next big one. It's whether we'll even bother to look for it in the first place.